brief lesson on thunderstorms and lightning. Thunderstorms are a series of sudden electrical discharges resulting from special atmospheric conditions. These discharges produce flashes of light and trembling sounds and waves, commonly known as thunder and lightning. The phenomenon is associated with convective clouds, and it's often accompanied by heavy rain or hail. The most common question always asked is what causes thunder and lightning? Thunderstorms develop when atmosphere is unstable. That's clear. When warm air finds its underneath colder air, that is the main unstabilizing aspect. As the warm air rises, it cools and condenses, forming small droplets of water. If there is enough instability in the air, the updraft from the warm air is rapidly going up, and the water vapor will quickly create clouds. Typically, these clouds can form in less than an hour through this process. As the warm air continues to rise up into the cold air, the water droplets combine to create a larger droplet. Those droplets is basically very small particles of water, which then freeze to form ice crystals. As a result of circulating air in the clouds, more water freezes within the clouds and more droplets crystallize. Eventually, those crystals, droplets as you were, get too heavy and are no longer supported by the warm updrafts of the air, and it falls heavily like hail. The water droplets, which is now hail, moves through the cloud, and as it picks up speed, it creates a negative charge by rubbing up against smaller positive charged ice crystals. Now you can only imagine this a bit like a battery. You got your negative and positive. If you were to rub those together, this is the action which is happening within the cloud. A negative charge can form a base of the cloud where the hail collects, while the lighter ice crystals remain near the top of the cloud and create a positive charge. So now we have two sides of the charge. One at the bottom of the cloud, one at the top of the cloud. The negative charge is attracted to the Earth's surface and the other clouds and objects. When the attraction becomes too strong and the positive and negative charges come together or discharged to balance the difference in flashing of lights, sometimes known as lightning strike or bolt, the electrons shoot down from the cloud, cutting through the air at around incredible speeds. It's said to be around about 270,000 miles per hour. The rapid expansion of heat caused by the lightning creates the accommodating loud clap of thunder, and that's the after noise of the lightning. Maybe one of the questions you're asking yourself now is, what is the difference between a lightning flash and a lightning strike? Although often assumed to be the same thing, there is a key distinction between the lightning flashes and the lightning strikes. A lightning flash is what you can see, but this is often made up of several individual bolts of lightning, which are pulses of electric current that occur separately, if only it's a second apart. The term lightning strike refers to a cloud to ground lightning, so the lightning current is leaving the cloud. So in effect, where the lightning hits or strikes the ground. As just explained, the most common way of a lightning storm being created, you need your positive and negative charges, which is the most common way. However, a bolt from the blue, which happens on the occasion, can actually come from a positive charged top part of the cloud, which is called positive lightning. When positive lightning strikes, it is forced to go round the negative charged base of the cloud. So again, we're now sidetracking the bottom part of the cloud, which generally results in a more powerful lightning strike that shoots out sideways and can sometimes travel a mile or more before connecting with the ground. This type of lightning strike is where we can get the term bolt from the blue. As we explore deeper into lightning, you will find that you can find and define types of lightning to 9 different categories. The first type of lightning is ball lightning, a rare form of lightning in which a persistent and moving luminous white or coloured sphere is seen. The second type is a pearl necklace lightning, a rare form of lightning, also termed as chain lightning, or sometimes known as beaded lightning, in which variations of brightness along the discharge path, which is the path the lightning is coming down from the cloud, gives rise to a momentary appearance similar to pearls on a string. The third type would be ribbon lightning, originally cloud to ground lightning that appears to be spread horizontally in a ribbon type of parallel illumination streaks. This occurs when there's very strong wind blowing at the right angle, which obscures the observer's line of sight. Therefore, you sort of have a mirrored effect, very fine, of lots of strikes in the same area. The fourth type, fault lightning, is a little bit more commonly seen. Many illumination branches of lightning from the main discharge channel are visible. Therefore, a lightning strike coming from the negative part of the cloud, the bottom end, hitting the ground, whilst it was travelling down that path, a variety of other lightning flashes are forking out, which is the best description for the type of lightning, forking out across the sky, not necessarily all striking the ground. The fifth type of lightning, sheet lightning, the popular name applied to a cloud discharge form of lightning in which the emitted light appears diffused and there is an apparent absence of main channel because of the obscuring effect of the cloud. This type of lightning doesn't actually strike the ground. It runs across the clouds, giving a large glowing effect through the discharge. In that sixth type of lightning is probably the most exhilarating lightning to see because it's very flammable. The lightning is very similar to fault lightning. However, if you could amplify fault lightning by 10, you will end up with streak lightning. And that type of lightning is a discharge that has a distinct main channel, so one strike down to the ground, and often branching off in many different avenues. This discharge from the cloud to the ground can sometimes occur from the cloud to the air, not necessarily striking the ground. The seventh type of lightning is referred to as sprites, which is an electrical discharge that occurs up high above the clouds of an active thunderstorm. It usually appears in a luminous reddish-orange plasma-like flash illuminating the sky. And the eighth type of lightning is known as blue jets, a bright blue discharge that projects from the top of the cloud above the thunderstorm to the lowest levels to about 40 to 50 kilometers above Earth. This is within the area they call a stratosphere. And finally, the ninth type of lightning is elves. This appears as a dim, flattened, expanding glow around about 400 kilometers in diameter that lasts for typically just 1 millisecond. They occur in the thermosphere, which is around about 100 kilometers above the ground. Thunder is the sound produced by lightning. When lightning strikes the narrow canal of air through which it travels almost instantly, reaching temperatures up to 30,000 Celsius. This intense heat causes the air to expand rapidly outwards into the cooler air surrounding it, creating a ripple shockwave that we hear as a rumbling thunderclap. Depending on its formation and location, this thunderclap can be heard as either a sudden loud crack or a long low rumble. Thunder lasts longer than lightning due to the time it takes for sound to travel from different parts of lightning channels. Although lightning and the associated thunderclap are generally simultaneous, thunder will always be heard after lightning strike is seen, because light travels significantly faster than sound. The speed of light is a whopping 299,792,458 meters per second, compared to the speed of sound 340.29 meters per second. A significant difference. Your distance from the thunderstorm can be estimated by measuring the time between seeing the lightning flash and hearing the start of the thunder. The length of this interval in seconds can be divided by 3 to give an approximate distance in kilometers. Sometimes lightning may be seen, but there is no thunder heard. This is because thunder is rarely heard more than 20 kilometers away, or because the atmospheric conditions lead to sound bending upwards and away from the surface. An interesting fact about lightning: the common question, does lightning strike twice? On the contrary to the popular saying, lightning does often strike more than once. The Empire State Building in New York is struck by lightning on average 23 times each year, and was once struck 8 times in 24 minutes. Closer to home, in the UK, the Shard in London, the tallest building in Europe, was struck multiple times during particular ferocious storms in May 24. Standing at 306 meters, it is a perfect conductor, and therefore it is likely to be hit. Thankfully, the tallest buildings are fitted with light protection systems which channel electricity from the top of the building to the ground safely. I'm now going to leave you with the 4 different types of thunderstorms you may experience. Each one of these thunderstorms have a rather complicated makeup and have different characteristics. So I do hope that you go and explore these different types of thunderstorms to gather a further understanding. But for this lesson, I'm just going to leave you with what they are. There are 4 types of thunderstorms: a single cell, a multi-cell cluster, a multi-cell line, and a supercell. And the type of thunderstorm you're experiencing mainly depends on the wind and the surface to the atmosphere of where the thunderstorm is developing. This will give you the measurement of which thunderstorm you're experiencing at a given time. Thank you for listening. I do hope you subscribe for other interesting videos. See you again soon.